3D printing, what's the big deal? Okay guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. Let's grab another small piece and move along. This is the chest packing gland. It's the little part that goes right here. There's about 30 thousandths worth of material to come off of this all the way around. We're going to have to face this one side off, turn this diameter, clean this up, get the gate off of it, and then we're going to have to put the holes in on the outside. Now, I've just recently viewed this particular process being corrected with some creative math, but gotta say, you don't want to do it that way because it dimensionally ruins everything. I mean, it's only a model, right? So make a bigger hole and it's not ruined. But I will explain exactly what's going on and why when I get to put these outside holes in. If you've already seen it done, you might want to think twice about doing it the way you've seen it done until you watch this one. Just saying. All right, going to start by putting this on a sander. I'm going to take these gates off on the sides, or these two features from the single gate, and blend it in and try to make it look like a single piece and a nice flat back, because that's a good place to start. All right, here we go. Okay, first operation, we're going to sand off the gate, and off camera I ran this across the piece of emery sitting on my bandsaw table, so it is nice and flat and clean, and it's as flat and clean as it needs to be, so that is probably a finished surface. Let's sand off the gate and put some holes in this. Watch your fingers. I'm going to finish that up with a file and make it look exactly like the other side. Off we go. time to put the mounting holes in. Now, chances are you've seen this done recently, and now you're going to see it done my way, which may or may not be the correct way, but yeah, we'll leave that to you to decide. Put the pin in the drill chuck. And let's just start the same way that it's been done. Put the pin in the drill chuck, right? Now let's say it's not straight, which is a problem that you may or may not have. It's no longer straight in line with the axis of the machine. So let us demonstrate the solution to that. A previously presented solution was, here's your 3-hole pattern. You want a hole here, and you want these holes to be in line because you want this component to sit on the casting correctly. Well, if you can't get the pin to come down, let's just do it so you can see what's going on. There you go. 0, 0, X0, Y0. Ideally, we want to be 250 off in both directions. But when I move 250 this way, and I'm not in the middle of that flange, oh, it's okay, because I'll just center it this way and record the number. And on the other side, I'll do the exact same thing. 250, and go back to the mirror or polar opposite of the other number, puts me in the center of the flange. All well and fine, but you just blew the part. That is not all well and fine, and this is why. You want the holes in line at a very specific dimension. This is the same as a 2-hole bolt circle. As soon as you make the shift off center from dimension X, now this is drastically exaggerated so you can see it happening. As soon as you move over to accommodate the casting, your holes are still in line, which is good. But now you've created a hypotenuse of the triangle, and this leg is a lot longer than this leg. So by making a correction to accommodate the casting, you have just missed the dimensions you're looking for. Do not do it that way. And I'm just going to come straight up and say it. It's wrong. It will eliminate the dimension that you are looking for, and you won't get what you had hoped that you were going to get. Now naturally this is only a model. It doesn't matter. Make the holes bigger if they don't line up, and then they'll line up. But let me show you a different, more reliable way to do this. Hang on a second. Using the exact same drill reamer setup that you used to put the hole in the middle of the gland, do it again. Drill and ream the exact same size hole in your little fixture plate. And this is just a piece of scrap aluminum. Double check everything with a pin in the chuck. life is good. Now instead of putting the pin in the chuck, put the pin in the plate. Put something under the pin so it doesn't fall through the plate. There you go. Halfway there. Put your part on that pin. Now it can just spin all day. It goes wherever it wants to go. Now is when you line it up with the second pin. Make the machine shift on the axis that you are going to be drilling on. In this particular setup, it is my y-axis. I'm going to go 250 off center. And I don't care where the part is right now. The table is correct, the center bore is correct, life is good. I'm going to bring the pin down and I'm going to visually line up the part by spinning the part on the existing pin. Okay, it's a visual thing at this point. Dimensionally, it is going to be spot on. Once you like what you see on one side, jump the center boss to the other dimension and visually checked out. Any corrections to be made, now's the time to do it. When you're happy with what you got, I'm going to keep the pressure on the part from the pin. I am pushing that against the table right now. I'm going to come back in with my fancy little clamp that I got. I'm going to clamp it down over the center. With the part clamped, now you can just jump over the center boss and drill both holes. Let's see if that works. I like it. This is a number 41 drill. 096. It's about 2.5 millimeters. And we're back. Camera battery died. Let's do the second hole. All right, now anybody that's been paying attention will know that this part is not the 1/4 inch long that it's supposed to be as per the print. It is my opinion that the extra material that's left on the face of this thing will ultimately come off, but it doesn't have to come off in the lathe just because it's round. A lot of people make that decision and say, well, you know, hey, let's just cut it in the lathe because it's round. You don't have to. And the final step in my approach is to rotate the part 90 degrees from where it was just positioned, add a second clamp to hold it flat against the fixture plate, and come down on top of it with an end mill just slightly larger than the boss. This will finish that sealing face with concentric scratches, not spiral scratches if it was done on the lathe. Anybody that's ever done a gland surface or a valve knows that concentric serrations are better than spiral serrations. And the difference would be a spiral serration is a phonograph record and a concentric serration is like the rings of Saturn. Once you're in a groove, you stay in that same groove forever. With a sealing surface, that's important. You don't want the fluid or pressure translating across the sealing surface just by migrating out like a horizontal or a spiral thread. So just take a dust off, come down to the surface that you want, And to set your tool height, register on the fixture plate itself, zero your tool, and then just come up or lower the table, and you'll know you have the boss height or the overall stack height of the component. I am making this boss height 100 thousandths. The print calls for 125, but the mating port in my cylinder is a flat bottom, so the gland material needs to have some place to expand, and I don't want to crack this casting when I torque down on the screws. This is a very minimal cut. The beauty of finishing this boss on the mill as opposed to the lathe, this particular process would allow you to have that center boss any height you want without worrying about holding it in a collet and having the part fly out of the machine, or crazy gluing it to anything and requiring a blowtorch to finish the part. This part is basically complete. And this is the final product. See that the holes are nice and clean, right where they're supposed to be. And anyone that's following this build may have noticed when I did this guy right here, I plunged this with an end mill. So this is a flat bottom port. The last thing you want is for this elevated boss on this component, when it goes down in here, to allow this flange to sit proud like that, because it is going to be compressing some gasket material or some seal to choke around the valve stem that goes in and out of here. Ideally, when everything is smashed the way it should, you want this as close to contact as possible so you don't crack the casting when you draw the screws down. With that in mind, this is 125 deep. I made mine 100 tall, 100 tall. I will have a 25 thousandths gap between the face of this component and the bottom of that bore, only because this is a flat bottom. If you use a drill like they say, you'd probably be better off with a full 125 on this projection. I made mine 100. And that is by design. Personally, I'm hoping the valve rod that goes through here is a little bit smaller than 125, because it's a 125 pin, and it's probably so tight it doesn't even need a seal. But that is tight. Anyway, there you go. Remember sit that on a pin and rotate the part. Please do not step off the center line trying to correct an error. All you're doing is increasing the dimension that you had previously set. Done. Move on. Next piece in line is this one right here. Valve chest cover. Looks pretty easy. Gonna put a flat on the bottom, gonna pop a couple of holes in it, and that is all she wrote. But there is a added benefit to this particular part, and this is the part. I just rubbed it across some emery, strategically placed on my bandsaw table because it's a cast surface and it's nice and flat, just to highlight those elevations. I think that looks nice that way. So I'm going to aim to put my holes right in the center of those. Print calls for cutting off the back, flattening out the back, clean up the back, and you can tell because this is the recessed side and that's the dotted line. Do not tap this down in the vise to do this operation. If there's any twist, warp, roll, wind, bend, deviation, distortion, or whatever else you want to tag it, when you hit it down, you'll flatten it out, of course. It'll come out nice and clean when you mill it, but when you open the vise, boing, it's going to go off back to where it was. So when you put this in the vise, set it in the vise, gentle finger pressure, and lock it down. Do not tap it. All right. And believe it or not, at that point, I'm not going to put the holes in. I'm going to flip it over and I'm going to do it completely different, and I'm going to show you why. Let's do it. Next step in the process is to just establish a reasonable gripping surface on the sides of this cover. I am not going to square it up. I am not bringing it to any type of dimension. I am just establishing a surface I can trust to hold in the vise. Both sides. Minimal cleanup. Okay, trustworthy parallel sides, straight, square to the back. I'm going to flip it over on the shiny little bosses on parallels and deck the rear of this part off. Cover is now sitting on a pair of parallels, lightly clamped, not tapped down. And here's a golden tip for you, something to consider. I'm going to fly cut the back of this part. This is a CNC tip, as well as a manual. If you set the sweep of your tool so that the circle it spins is bigger than the actual part, when this tool traverses that part, now stick with me for a second, all you manual guys, as this tool is swinging and you traverse this part, when you are done with that cut, when that part is now clean, you can stop feeding right now. You don't have to worry about coming all the way across like a lot of people do. Let's see what the back side of the tool does and continue to feed, because this is all wasted motion. It's all wasted time. And if you're doing a lot of parts in a production run, as soon as the footprint clears the part, that is the end of the trajectory right there. End it, get the part, or excuse me, get the cutter off the part. Let's clean the back of this thing up and move on to the next step. Okay, right there is where I'm going to stop this cut, and it is absolutely ideal. You are just seeing a reflection right here. That is not the casting showing through. There is no sense in proceeding with this cut. It's a waste of time. Now this is a gasket surface, so you do want it to be relatively clean. And use a big cutter as you can for stuff like this. Smaller stuff, it really doesn't matter. This one, yeah. I'm going to take it out of the vise, wipe it on a piece of emery, make sure it's nice and shiny, deburr the edges, and we'll move on to the next step. You're going to like it. Alrighty, here's the setup for the holes. I've got it on top of a sacrificial plate, 4 clamps on it so I don't drill into the clamps. And everybody that's slapping themselves in the forehead and typing a nasty comment right now, hang on a second, because there's a surprise here. Let's drill some holes. I'm looking for nice clean holes here, so I'm going to go around with a center drill first, a 1/8 drill, and then a 9/64 4-flute end mill. Alright, let's switch over to the end mill. 9/64 4-flute carbide end mill, loaded and ready to go. You have exactly 6 holes to figure out what the surprise is here. See if you can pick up on it. One more hint. That is all the hint you get. If things went well, then you get the surprise. If things didn't go well, then I get the surprise. So let's pop these clamps off of here and do the big reveal. Here we go. If there was a band standing by, this is where I would say, drum roll please. You're gonna like this one. I promise you're gonna like this one. Yipper. Put your gasket material under your subplate or under your head, cover, drill it at the same time. You just made the gasket or the cover. It just doesn't get any sweeter than that. Boom. Okay, take a look at the progress. Since this is sandwiched against a slave plate or a backup plate, the chipping on the back sides of these holes is absolutely non-existent. With a continuous surface, absolutely beautiful. Minimal deburring around the top. The visual alignment, I put a pin in my drill chuck and I swept from one side to the other, split the difference on my DRO, did exactly the same thing lengthwise, came up with my center, and then visually checked the pattern before I proceeded. You can see that the casting is skewed a little bit, but it's going to be spot on when it comes time to mount it. Everything will line up. No transfer screws necessary, no goofing around, no transfer punches. Hit the numbers on the print, both parts, everything should line up. Double check the print before you do it. And that little bonus that I don't think you saw coming. Squeeze a piece of gasket material underneath the cover before you drill it and make yourself a gasket at the exact same time. The print does call for about a 5/16 perimeter all the way around. I will lay that out with a pen and cut it with an X-Acto knife. I don't see any reason that it has to be hollowed out other than the fact that it'll look like a better gasket. But there you go. Done on a mill. That's a freebie right there. Well worth the time it took to set it up. I hope you like what you're seeing so far. Thank you for tuning in. Stay well. Joe Pye, I'm out.